The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to start section 3 or chapter 3 or objective 3 or whatever you want to call it. Anyway, we're going to look at 3A, which we will get started on here right now. All right. Suppose you have 3 apples and your friend comes over and gives you a bag of apples, and in the bag there are another 12 apples. What's the total number of apples you have now? Well, you would take 3 apples plus 12 apples, and you would say, I have 15 apples, right? Okay, so apples is what you've got, and 3 and 12 is how many of them you've got. And to get the total, we add the how many. The how many is called the coefficient. So the coefficient here is 3, the coefficient here is 12, 3 plus 12 is 15. So 3 apples plus 12 apples equals 15 apples. All right, suppose you've got 4 apples plus 3 bananas plus 5 apples. Well, we can't combine apples and bananas. I suppose we could call them panas or bananals or something, but typically we don't do that. I saw that smile, Courtney. All right, now, but we could say that we have 9 apples plus 3 bananas, right? Because apples and apples, we can combine those into a total number of apples. All right, well, let's go back here for a minute. Let's say that instead of apples, we had some unknown quantity, and we were going to call that A, or we have some unknown object. We're going to call it A. And I have 3 of those plus 12 of those. So 3 is the coefficient of the variable A, and 12 is the coefficient of the variable A in the second term. So 3A plus 12A would be 15A. Any questions about that? All right. In this example, let's say we had 4A plus 3B plus 5A. We could combine the 4A and the 5A to get 9A, and then 9A plus 3B, excuse me. All right. The 4A and the 5A are what we call like terms. They contain the same variable, but they may have, in this case, they do have different coefficients. 9A plus 3B cannot be combined. They are called unlike terms. And that's as far as we can go to condense or simplify what we have there. Any questions so far? All right. Suppose we have the following: 8x minus 3x. So 8 of something minus 3 of something would be 5 of something, the something being x. So 8x minus 3x equals 5x. Any questions about that example? All right. 9w minus 4w equals 5w. Again, we're, in this case, subtracting the coefficients. How about x minus 4x? Well, what if I said I have banana? I have banana. How many bananas do I have? If I just say, oh, I've got a banana, 1, right? Now, if I said I have bananas, then it'd be like, well, how many bananas? But if it's singular like this, we know that means 1 banana, okay? So here, where we have X, that's the same thing as having 1X. That does not mean that the variable X stands for the number 1. It means that X is equal to 1 times X. In fact, X is equal to 1 times X to the 1 power all over 1. We've got all that extra fluff there if and when we need it. But my point is, this is 1x minus 4x, which would be negative 3x. 1 of something, take away 4 of something, you're in the hole, 3 of something. We okay with that? Any questions there? All right. Let's say I've got 1/4 y plus 3/4 y. Well, I would, since the terms are like terms, they both contain the variable y, I would add the coefficients. 1/4 plus 3/4 is 4/4. So we have 4/4 y, but 4/4 reduces down to 1 y, and we don't need to put the 1, it's implied. So the final answer would be just y. All right. What about this situation? 4x over 5 plus 3x over 4. These are like terms. They both contain the variable x. However, we can't just add those like terms right away because the coefficients, the fractions, don't have a common denominator. Well, what's the least common denominator of 5 and 4? It would be 20. So what we've got is this. To get from 4/5 to something over 20, well, 4 times 5 is 20. 4 times 4x is 16x. So 4/5 x becomes 16/20 x. Any questions there? All right. 3/4 x, we'd multiply the 4 times 5 to get 20 in the denominator. So we'd multiply the numerator by 5 to get 15x. 16/20 x plus 15/20 x is 31/20 x. Now, you could rewrite this as 1 and 11/20 x, but in algebra, we tend to avoid mixed numbers unless it's appropriate. So even though this is correct, this would be a more appropriate answer. Now, when would a mixed number be appropriate? If I said, go to the fabric store and get me some fabric, and I needed 3 1/3 yards, even though that's equivalent to 10/3 yards, I probably wouldn't say, get me 10/3 yards, right? In that context, the mixed number is more appropriate. It doesn't mean that this is wrong, it's just not appropriate in that context. Well, in algebra, unless there's units involved, like yards or miles or hot dogs, whatever, we tend to use improper fractions or proper fractions or decimals, but we tend to avoid a mixed number as a coefficient. Any questions about that?
Does it matter when you move the x around?
Say that again. What? Yeah.
Does it matter when you move the x around? So like 15x over 20 or 31 over 20x?
Good for you for picking up on that. So let's go with 15x over 20 or 15/20 x. These are equivalent. What you don't want to do is this. So the x is in the implied numerator. you can either actually put it above the fraction bar, if you put it kind of straight out from the fraction bar, that implies it's like it's 15/20 times x over 1, but we just write it like that. But you don't want to have it dip below the fraction bar. That's an entirely different thing. So yeah, this form, yeah, and this form are the same thing. Okay. Any other questions about the notation? All right, excellent. Let's see here. Let's say I've got 4.2x minus 2.9x. Well, let's see. 4.2 minus 2.9. We bring the decimal point down. That's what? 1.3x. Okay. How about this? Negative 3.6b plus 0.9b. Well, let's see here. Negative 3.6 plus 0.9 equals negative 2.7b. Questions there? All right. What if I have the following? Negative 6 plus 6y minus 3. Well, negative 6 minus 9, minus 3, excuse me, would be negative 9 plus 6y. Now, if you're really awake this morning on this Monday, which I know I'm not, but maybe you are, you might say, well, doesn't order of operations say to do addition and subtraction from left to right? So how is it that I can jump past this and get to that minus 3? Well, consider this. You can legally change addition into, subtraction into addition of the opposite. So minus 3 could become plus negative 3. Also, we talked about how addition and multiplication are commutative. So we could now change the order of the terms being added. So now I can do this. Now, it doesn't mean you have to go through all these steps to get there. I'm just justifying the legality of doing that. Okay. Likewise, I could write this as 6y minus 9, because I could write it as 6y plus negative 9, but that's the same thing as 6y minus 9. Okay. Let's see. What if I had this? 3m minus 8y plus 6m. So combining like terms, I'd have 9m minus 8y. Any questions there? Okay. What if I had 5x minus 3w plus 7x plus 11w? Combining the x's, 5x plus 7x is 12x. Combining the w's, minus 3w plus 11w would be plus 8w. I can't put the x's and the w's together because they are not like terms. It's like apples and bananas. You could make fruit salad, but it's not, they're not the same fruit. Okay. Let's see here. Hang on just a minute. Okay. How about this one? 12y plus 8y squared minus 3y squared minus 19y. Now, all of the terms contain the same variable. However, y is not the same as y squared. Even though they are both the same variable, they are different powers of the variable. Therefore, something with a y in it and something with a y squared in it, they are not like terms. So we could put the y's together, 12y minus 19y would be negative 7y. And the y squareds together plus 8y minus, plus 8y squared minus 3y squared would be plus 5y squared. Also, when we're simplifying an expression, and it just contains one variable, as in y, we tend to put the terms in decreasing order of the powers of the variable. So the best way to write this would be like that. This is okay, this is even better. Any questions about that? All righty, let's see here. How about this one? And again, if I'm going too fast, let me know, I'll slow down. 1/6 A minus 3/4 B plus 1/4 A plus 5/6 B. Well, I have some like terms. Those are like terms and those are like terms. But to combine those like terms, I need a common denominator. The first thing I'm going to do is I'm going to rewrite these so that the like terms are next to each other. You don't have to do this step, but it might help you to organize things a little better. So now, putting these together, the least common denominator of 6 and 4 is 12. Okay. So I'm going to multiply the 6 by 2 and the 1 by 2. So 1/6 becomes 2/12. 1/6 A becomes 2/12 A. 1/4 A, I'm going to multiply the denominator by 3 to get a new denominator of 12. I'll also multiply the numerator by 3. So I get 1/4 becoming 3/12 A. Now I'm ready to combine the two coefficients. 2/12 plus 3/12 is 5/12, and it's 5/12 A. I can't reduce 5/12. If I could, I would, but I can't, so I shan't. All righty. Moving on now, the least common denominator, 4 and 6, again, is 12. So this is minus so many 12ths B plus so many 12ths B. I'm going to multiply the 3/4 by 3/3. So 3/4 becomes 9/12. So I get minus 9/12 B. I'll multiply the 5/6 B times 2/2. So we get 10/12 B. Minus 9/12 B plus 10/12 B is plus 1/12 B. So my final simplification, 5/12 A plus 1/12 B. Any questions about that? All righty. Let's say we're going to go out for a burger and we go to some hamburger place and I order a hamburger. Let's see, hamburger and some fries and a drink. Okay. And I'm going to buy you lunch. I'm going to buy you the same thing. So I tell the clerk behind the counter that I want 2 orders. Okay, 2 combo meals of a hamburger, fries, and a drink. Okay, so because we're not going to get it to go, we're going to eat it right there. They bring it out on a tray. And what is on the tray? Well, there are 2 hamburgers and 2 fries, not 2 fries, but 2 containers of fries. and 2 drinks, right? So if we have 2 of a bunch of stuff, we have 2 of each thing within that bunch of stuff. That's very mathematical. Write that down, bunch of stuff. Okay, this is known as the distributive property. It's where we're multiplying a number times a group, which is typically grouped inside parentheses. So we're distributing across the parentheses. 2 of this plus 2 of this plus 2 of that. Okay, now what does that look like mathematically? Let's see, H, F, and D. Suppose I've got H plus F plus D, and I've got 2 of that. Excuse me. I would have 2H plus 2F plus 2D. So I'm distributing the 2 across the grouping symbol of parentheses. Any questions about that? Now, when you're simplifying expressions, if you can get rid of parentheses, you do so. In fact, in WAMAP, in this particular assignment, one of the things that it says in just about every question down below the problem, it says, do not use parentheses in your answer. So basically, you're getting rid of the parentheses. Okay. Now, let's say I have this problem. 5 times the quantity, y plus 3, minus 7 times the quantity, 4y minus 2. Okay. So I'm going to distribute the 5 across the y plus 3. 5 times y is 5y. 5 times a plus 3 is plus 15. Any questions so far? Now we're going to distribute the minus 7 because we're subtracting 7 of everything inside. So minus 7 times 4y would be minus 28y. But now minus 7 times a minus 2, minus times minus is plus 14. Any questions there? So now I've distributed, I've done the multiplication. So going down order of operations, next we would do addition and subtraction. We're going to combine like terms. Those go together and those go together. 5y minus 28y would be negative 23y. And 15 plus 14 would be plus 29. So there's the final answer to that problem. We're simplifying it. The directions say simplify. Any questions there? All right, let's take a look at another example. 8w minus the quantity 4 minus 3w plus 8. Order of operations says do what's inside grouping symbols first. 4 minus 3w, those are not like terms, so we can't combine them. So we're forced to distribute. What are we distributing? Well, if I've got this minus a quantity, that's like minus 1 times a quantity. So basically, we're going to distribute a minus 1, or just a negative sign, if you will. So what am I going to get? Well, I'm going to get 8w minus 4. Minus times minus is plus 3w. The plus 8 at the right end is not inside the grouping symbol, so we don't distribute the subtraction sign to that, so then plus 8. So these come down, and this, the subtraction sign gets distributed, which changes the sign of each thing inside the grouping symbol. Any questions there? So now combining like terms, 8w plus 3w is 11w. Minus 4 plus 8 is plus 4. So there is our final simplification. Okay, let's see here. Questions? All right, let's take a look at this problem. 9 minus 6 times the quantity x minus 8 plus the quantity 7x plus 2. Now, we need to be especially careful not to violate order of operations. Order of operations, we have what? Grouping symbols, exponents, multiplication and division, whichever comes first from left to right, addition and subtraction, whichever comes first from left to right. The distributive property lies under multiplication because we're taking what? Minus 6 times x, minus 6 times minus 8. What you need to be careful of is not to do that first. Don't go, oh, 9 minus 6 is 3 and then distribute the 3, because that would be doing subtraction before multiplication, which is not correct. Okay, so be careful. So what we are going to get here is 9 minus 6x minus 6 times minus 8 is plus 48. Then having a plus sign in front of a parentheses, it's like having a minus sign and that there's an implied 1. But with a plus 1 times something, you just get plus what's inside the parentheses, right? Because distributing a plus 1 doesn't change what's inside the parentheses, but it allows us to get rid of the parentheses. So we've gone through now and done all of the multiplication using the distributive property. Now, I'm going to combine like terms. This and this and this go together, and that go together. But at the same time, I'm going to put it in standard form. That is, I'm going to put the term with the variable first. So minus 6x plus 7x would be 1x, but I don't need to write the 1 in front. Then 9 plus 48 is what? 57 plus 2 is plus 59. Now, again, if you wrote 59 plus x, that is a correct answer. This is just better, getting you ready for what's coming later. So again, any question about anything there? Right, just a minute here. Okay. So here we have the quantity 3x plus 5y minus 7z plus the quantity 5z minus 2x minus 5y. There is nothing in front of the first set of parentheses. So basically there's an implied 1. If I have a group of stuff, I've got one group of stuff. Well, distributing that 1 basically just gets rid of the parentheses. So this becomes 3x plus 5y minus 7z. Having the plus sign in front of the second grouping symbol is like we're going to have plus 1 of something. So distributing the 1 gets us basically what's inside, plus 5z minus 2x minus 5y. Now that we've gotten rid of the grouping symbols, we're free to roam about the country. We can add and subtract like terms. What I'm going to do is I'm going to put the like terms, I'm going to put them so that they're in alphabetical order. You don't have to, but it's just kind of a thing that math people do sometimes. So let's see. I'm going to put the x's together. 3x minus 2x is 1x, or just x. 5y minus 5y is 0y. And at this point, I don't need to write plus 0y. Basically, those are just going to cancel each other out. And then minus 7z plus 5z would be minus 2z. So x minus 2z would be the final answer. Okay. Any questions? Doing all right? Suppose we have a scenario where we're distributing through some decimals. So we've got like this, 5 times the quantity 2.8 m plus 4.2 n minus 7 times the quantity 9.2 n minus 3.5 m. Inside the parentheses, I can't combine things. They are not like terms. M and N aren't the same. So I'm going to distribute the 5. Well, let's see. What's 5 times 2.8 is 14m plus 5 times 4.2, 21n. Then minus 7 times 9.2n is minus 64.4 n. Don't forget to put the variable. And then minus times minus is going to be plus, let's see, 7 times 3.5 is 24.5 m. Okay. So I've distributed, I've gotten rid of the parentheses. Now, combining like terms, I'm going to put the m's first. 14m plus 24.5m is 30, whoops, let's go back to the black there, is 38.5m. And then plus 21n minus 64.4n is minus 43.4n. Careful that you don't get your m's and n's mixed up. Any questions there? All right. Let's take a look at, let's see. Oops, hang on here. This one. 2/7 times the quantity 5x minus 14w plus 4/5 times the quantity 15x minus 7w. The directions say this: do not use parentheses in your answer. And then it says below that, if needed, write the numerical coefficient as a reduced fraction. And we'll talk about that as we go here. Okay. So inside the first parentheses, 5x minus 14w, Those are not like terms, so I can't combine them. So I'm forced to distribute the 2/7. So we're going to get 2/7 times 5x, and that 5x is over an implied 1. And that would end up being what? 10/7 x. And then distributing minus 2/7 times 14w over 1. And I put the minus that was with the 14, I just put it out in front there. Any questions about that? Now this I could reduce down. 14 over 7 is 2 over 1, so we get minus 4w. Let's clean that up a little bit. So far, so good? Okay. Plus 4/5 times 15x over 1. The 15 over 5 is 3 over 1. So we get plus 12x. And then minus 4/5 times 7w over 1. And that doesn't reduce any, so we get minus 28/5 w. So I was able to reduce some of those products here and here, but not all of them. Now, combining like terms, the w's go together, the x's go together. Well, let's see here. Oops. Keep trying to change the color. I'm not hitting it hard enough. There we go. Okay. So negative 4w minus 28/5 w. That would be like negative 4 over 1 w minus 28/5 w. The least common denominator of 1 and 5 is 5. So we're going to have that. The second fraction already has the common denominator. So the first fraction, negative 4 over 1, will multiply by 5 over 5 and get negative 20 over 5. Okay. So I've got negative 20/5 w minus 28/5 w. So far, so good. Now, going on, I've got, let's see here, let's get this out of the way. Let's see, going after that, I've got what? Plus 10/7 x plus 12 over 1 x. Common denominator of 7 and 1 is 7. So plus 10/7 x plus so many 7ths x. I'd multiply the 12 over 1 by 7 over 7 and get 84/7 x. I'm going to recopy this whole thing on the next page. All right. So minus 20/5 w minus 28/5 w plus 10/7 x plus 84/7 x. Get that right? Yeah. Any questions on this page? Can I go ahead and go on? I'll take that as a yes. All right. So negative 20/5 minus 28/5 would be negative 48/5. fifths W. 10/7 plus 84/7 would be 94/7 X. Now, can I reduce? Not change to a mixed number, but can I reduce it? 48/5 doesn't reduce. 94/7 doesn't reduce. So this would be my final answer. Any questions there? Let's see here. How about this one? Six X plus 8Y minus 14Y minus 9X plus 3X minus 2Y. Okay. So there's nothing in front of the first set of parentheses. So it's like we're just distributing a 1. So we get what's inside. The second set of parentheses has a minus sign in front. So distributing minus times 14y is minus 14y. But minus times minus is positive or plus 9x. And then having a plus sign in front, distributing that, it's like distributing a 1. So we get what's inside again. Okay. So having nothing in front or a plus sign in front, you just bring down what's inside. Having a subtraction sign, that changes the sign of everything inside the parentheses. So now, combining like terms, 6x plus 9x is 15x plus 3x is 18x. (8y minus 14y is minus 6y, minus 2 more y is minus 8y. Now, let's talk a little bit about vocabulary. Again, all these directions in WAMAP, they all say simplify. None of them would say solve because we aren't solving an equation. These aren't equations. These are just expressions that we're simplifying. We'll get into using the word solve when we actually have an equation, and then we'll end up solving it. But this would all just be simplify. Okay. Well, that's all I've got for you today. I'm sure that's enough to keep you busy. Any questions? Let me find the mouse here. We'll stop the recording.